So every pair of documents you need to be choose, then you have to go for comparison. In that case, suppose you have okay, n docs are there, definitely how many comparisons you need to be made? N into n minus 1 only. N into n minus 1. So the pair you are using that divided by 2, which might be the value is going to be so the number of comparison you required 5 into 10 to the power 11 comparisons are required. Suppose that you need to be okay. That means these many comparisons you are performing. So or 10 to the power 5 seconds or per day you may perform, and 10 to the power 6 comparisons per second. It would take at least 5 days, okay, to complete this particular similarity check, right? So because of that, we should go for okay, n equal to 10 million. It takes more than a year. Suppose okay, suppose okay, this kind of algorithm you may use, it will take a 10 million. If n value is going to be, that takes more than a year. So this kind of solutions are not okay useful. So because of that, we need to go for a min hashing, convert large set into short signatures while preserving similarity. So here, how we will do the encoding? So here, many similarities problems can be formalized as finding subsets that have significant intersections. That means what we need to go for encoding with help of zeros and ones, Boolean okay, information. You need to be supposed to be used. So you need to be find the set intersection, and that can be useful for your bitwise okay, AND operator or bitwise OR operator. Means okay, if suppose you may take a C1, C2 here an example, you take the size of the intersection is going to be 3, size of the union is going to be 4. Size of the intersection is going to be 3, size of the union is going to be 4. Right? So that if in that case you need to be calculating a Jaccard similarity and the distance, Jaccard distance. So the Jaccard similarity is going to be, it's not a distance, it's going to be 3 by 4, and 1 minus the Jaccard similarity is going to be, sorry, 3 by 4, and okay, distance is going to be, sorry, Jaccard similarity is going to be 3 by 4, and Jaccard distance is going to be 1 divided by 4 because 1 minus Jaccard similarity. That's right. So what they are okay, saying to us, you have to take your shingles as a rows and documents as a columns. Means typically as matrix is parsed, that means you need to be choose this way. Rows are going to be your shingles, columns are going to be your documents. So here what you need to be understand, so one in a row E and column S, if and only if E is a member of S. E is a member of S. The column similarity is the Jaccard similarity of the corresponding sets. Okay. So we'll see with an example we will understand. Suppose you take these rows are going to be shingles. That means okay, you have to write okay. Suppose some single means okay. Suppose I may take example. Suppose okay, B E A X. Suppose Bx. That it means so I have to choose my row values are going to be B E A X. And here, what documents are there? Documents are going to be, you need to be treated as a subject, then S1, S2, S3, S4. So here, suppose I may write S1, here I may write S2, here I may write S3, here I may write S4. And you have to define your shingles. The shingles are going to be, suppose B, E, A, X, etc., is there. So now you need to be observed. Here this is 1, which means one means what? This B is a member of S1. This B is a member of S2. This B is a member of S3. That means okay, S1, S2, S3, S4 are what? These are documents. Are you clear? Any questions here? Please, okay, anybody, if you are unable to understand, please let me know. This is a Boolean matrix. The Boolean matrix is going to be used to develop your min hash. For that, you need to be choose your rows as shingles and columns are as your documents.
Yes.
Right. So we have to use this way, and we need to be find okay. Each document is a column. Each document is a column. That means S1, S2, S3, S4 are columns. So each document is a column. So now we have to go for, okay, suppose these are C1, C2, C3, C4. We need to go for compute the similarity of C1, comma C2. First, we need to be observe what is the intersection. What is the intersection? Intersection is 3 between two documents. And union is how much? Hello, Ahmed. Good afternoon. Okay. मैडम दीपक बढ़िया इज दैट मैडम आपका सही नंबर दीपक बढ़िया हाँ यस मैडम if you have okay otherwise I am in the class once class is over then I will okay, let you know I will okay, send him to you huh? Yeah no issue madam no problem fine sorry each document is a column and we need to be compute the similarity. Now we have a two C1, C2, two are there. Between these two documents, we need to go for similarity. In the similarity, you need to be find what is the intersection of these two and what is the size of these two. What is the size of these two? Suppose you observe. Okay, can you anybody can okay observe over here? Sorry. Anybody can observe over here how we can write intersection and how we can write intersection. And suppose you need to be consider the one here one is there, here one is there, here one is there, here one is there, and here one is there, here one is there. So the intersection portion is going to be 3. How we need to be go for size of union 6? In the size of union 6, if suppose we try to understand in this particular discussion, we need to be observe, okay? Additionally, how many, okay, here we observe, okay, 1, 2, 3 are there, as well as 4. Here, okay, these two are 1, that's why this is 5. This is 6. So union is going to be 6. Now we need to be calculate the Jacquard similarity. The Jacquard similarity is going to be for these particular two documents. Is how much? 3 divided by 6. And Jacquard distance is going to be 3 by, that means okay, 1 minus 3 by 6, that is going to be equal to 3 by 6. Am I correct? Now suppose you may take this way. Suppose we have a document, so this one is going to be C3 and C4. Okay, can you calculate the C3, C4 and can you calculate the intersection as well as the union, find the Jacquard similarity and the Jacquard distance? Can you post it on our chat group? I will just, I'm going to be observe that one. Raju sir, I am in the class sir. Shall I call? Sir. हाँ ठीक है सर आप ले लो सर ओ नरेंद्र गोदर से बात करके ले लो सर हेलो students you understand my question all of you understand my question? Yeah, you need to be go for okay D3, that is C3 C4 documents, find the similarity and distance. Simple. Just you need to be post it on okay your our chat box. Only one Gautam is answered. I'm showing this okay slide to you. Just I will come back to how many of them are you answered for this. I will check it out. Just you note it down this one. Okay, here 2 answers, 2 students only answered for me. I need okay two maximum people needs to be answered for the same. To solve this one and provide it. First you need to be right intersection and union, then the similarity and distance. So all of you understand who are I'm expecting everybody has to answer for this. Yeah, you should okay. Very easy to okay say that. The same thing. Can you do it for okay C2 C3 quickly? You can solve for the C2 C3 also. So just I'm showing the okay C2 C3. Just you remember. You just okay find out what is the intersection. Intersection is these two documents. Now intersection is 2 and union is 5. So similarity is going to be 2 by 5 and the distance is going to be 3 by 5. Right? So this is the way if any documents are given to you, you need to find the okay Jacquard similarity and Jacquard distance. Why? Because of this, okay, this is going to be mean hash is going to be useful for the same. Right. Now we will come back. So this is about the Jacquard similarity and Jacquard. So documents a set of shingles. We understand we are representing set of as a Boolean vector in the matrix. Our next goal is going to be find similar columns while computing small signatures. So similarity columns is equal to similarity of signatures. So our main goal here, similar columns, similar signatures we need to define. There are there are approaches are there. We are using an AVI approach. In the AVI approach, signatures of columns, we are going to treat it as a summary of columns, small summaries of columns, and examine pair of signals to find similar columns. Essential similarities of signatures and columns are related. The optional is going to check that columns with the similar signatures are really similar or not. So here, while you are doing this one, comparing all pairs may take too much time, so that you need to be use a locality sensitive okay, hashing. So that methods can produce okay, false negatives and false positives. That we will discuss in this particular discussion. So we are going to understand about the signatures. So the signatures we are going to be call it as a hashing columns. Hash each column C to a small. That you can treat as your signature H of C. So such that H of C is small enough that the signature fits in rank. Okay, and as well as your similarity C1 C2 is the same as the similarity of signatures of H of C1 and H of C2. So these two conditions you remember it. So our goal is going to be find hash function such that if similarity is going to be C1 C2 is high, then with a high probability H of C1 is equal to H of C2. If similarity C1 C2 are going to be low, that indicates to you the high probability is going to be C1 is H of C1 is not equal to H of C2. So the hashing we will generally use the buckets, and the buckets is going to be used all okay. It's going to pay mostly. It is going to find the near duplicate documents hashed to the same bucket, so that we know of bucket sorting. The same way you have here also you need to be used 0 to 9. Each one you need to be mapped. Why? Because the hashing is going to be used signature, the integer values only we were going to use. So the main target here we try to understand that is going to be min hashing. And the min hashing, find a hash function h such that this is the high and low we are finding. So here you try to understand. Here this is okay. This condition and this condition you need to be keeping. So whenever it is high, then the high probability is going to be h of c1 is equal to h of c2. If similarities are going to be low, then even h of c1 is not equal to h of c2. So what we need to be understand from this, the hash functions are going to be depends on similarity matrix. So and okay, one more point which we need to be understand. So all hash functions may not be use the same similarity function. So we try to understand a suitable hash function for Jaccard similarity. Then we call that as a min hashing. So what is the min hashing here? Anybody can tell me what is the min hashing? Min hashing means a suitable hash function for Jaccard similarity is called min hashing. The definition is very clear to all of you. So you can say if you anybody understand the min hashing, you can say yes. If you are not understand, you say no on the chat box. Okay, thank you. Few answers I received. I'm expecting more answers from the students. Right. So here we try to understand the min hashing means a suitable hash function for the Jaccard similarity. We'll see with the, how min function is supposed to be used, min hash. So if you have Boolean matrix which is going to be permitted under a particular random permutation, that is going to be pi over here, you need to be observed that this is okay, a random permutation pi we are using here, so that we are okay defining our hash function h of pi of c, that it means the index of the first row in which column c has value 1. This is you need to be remember very well. So what is the hash function h of pi of c? The index of the first row in which column c has value 1. So that's why h of you remember this one. You remember this one, h of pi of c, which is going to be equal to min pi of pi of c. Right. So usually we will use so many independent hash functions. Every column you need to be observed. Each column you need to be find. Where is the one, and whenever the one is there, that you need to be treated as your hash value, and that is going to be used to create a signature of your column. We'll see that. Just a minute, I will come back. Hi, madam. Hello. Hi. Hi. Good evening, madam. can we discuss at 5 o'clock because I'm in the class? If, at 5 we will discuss, no issue, right? Thank you. Yeah, here you need to be observed. So these are okay. This portion is belongs to documents. Am I correct? And this portion is belongs to our shinglings. Okay. So now we need to be go for permutation pi. If you go for permutation pi, the permutation pi is going to be 2, 3, 7, 6, 1, 5, 4. 2, 3, 7, 6, 1, 5, 4. Okay, with a small example, we are going to be understand. The signature of the matrix is going to be defined. So 2, this is 1, this is 2, this is 1. Right? So here you need to be observed. The second element of the permutation is the first to map to A1. First to map to A1. So that what happens? If you will go for next one, the next one is going to be, again, you need to be observed 4, 2, 1, 3, 6, 7, 5. Right? The signature of the matrix will come here. Okay, 2, 1, 4, 1. Next one, you need to be go here, you need to be observed. The fourth one, here, the third element is going to fourth. Fourth element of the permutation is the first to map to A equal to 1 over here. So these are the random permutations. Accordingly, the signature matrix is going to be comes over here. Right, and you have to go for the next one. Anybody can guess? Okay, what is the next? So here you need to be observed. Okay, another equivalent way to is the row indexes are going to be 1, 2, 6, 5, 3, 4, 1, 1, 6, 5, 3, 4. Right? So such a way that we need to be develop the min hash property. Such a way that we need to be develop the min hash property. So in min hash property, first you try to choose a random permutation pi, and you need to be compute the probability of okay h of pi of c1 is equal to h of pi of c2, then that is going to be equal to your similarity c1 c2. So now here one example is there. One of the two columns had to have one at position y, so that let x be the documents, y is belongs to x is the shingle, and then the property is going to be need to be used probability of pi, which is going to be equal to min of pi of x. That is going to be approximately equal to 1 divided by the length of the capital X. So with help of this one, we try to find out y is belongs to x, which is going to be mapped to the minimum element. Let suppose let y be is there such that you need to be find pi of y, which is going to be min of pi of c1 union c2. In other way, we can write pi of y is going to be equal to min of pi of c1 if y is belongs to c1, or pi of y is going to be equal to min of pi of c2 if y is belongs to c2. So based on this probability, we need to be okay. So suppose the probability that the both are true, then the probability of y is belongs to c1 intersection c2. So finally, we need to be observed over here the probability of min of pi c1, which is going to be equal to min of pi c2, which means c1 intersection c2 divided by the length of C1 union C2, which is going to be equal to similarity of C2. That it means what we are proving. So this particular probability is there. This probability is going to be equal to sim of C1 C2. The proof we are providing here to understand everyone to know. So this particular probability of min pi of C1, which is going to be min pi of C2, that is going to be equal to similarity of C1 C2. So we understand now similarity of the signatures we are going to discuss. In that case, we understand the previous slide, we understand probability of h of pi of C1, which is going to be equal to h of C2, that is going to be equal to your similarity C1 C2. So now this way you can generalize and you can create a multiple hash functions, so that the similarity of two signatures is the fraction of hash functions in which they agree. So because of this mini hash property, similarity columns is the same as the expected similarity of the signatures. Again, we will come to understanding about this particular example. We need to go and find the similarities over here. Okay. In this case, suppose if you have a permutation, random permutation is there over here, and you calculate the signatures like this. Now you need to be observed. Okay, 1 3 2 4 1 2 3 4. Then here you will find this particular column by column is equal to 0.7 and signature by signature is going to be 0.67. Okay, such a way that you need to be find the similarities for 2 4 and 1 1 2 3 4. Okay, you will find the values. So the main point over here to discuss the pick k equal to 100 random permutation of the rows, right? And you have to be find signature of C as a column vector, and with help of that you try to calculate the signature of C of pi, which is going to be equal to min of pi of C. So finally we are compressing long bit vectors into a short signature with help of this one. So that you have so many shinglings are there, the shinglings we are reducing and we are creating the signatures. The signatures are we are using, and the signatures are going to be comes to a very very small value, right? So implementation trick is there. What is the implementation trick? Permitting rows even once is prohibitive. That means row wise hashing you need to be performed, so that you have to pick k equal to 1 hash functions. Then ki is there, so you have to give a random row permutation for this ki. Once you computed that one, you have to go each column C and hash function k and keep slots for min hash value, so that you need to be initialize your signature C of I is going to be equal to infinite. Can the rows looking for ones. Once you find the one, suppose there is a row J that has 1 in a column C, then for each k of I, you need to be substitute like this. If k of j is less than signature of C of I, then signature of Ci is going to be kij. How to pick a random function of h of x? Universal hashing is there. You use h of a here this is there. So you use h of a comma b of x is going to be equal to a minus a into x plus b of mod p of mod n. A, B are random integers and t is going to be the prime number. So this is the way you can create your universal hashing function. So this is about the min hash. Any questions over here? Please let me know. Any questions I may expect from one of you?
Sir, may you please explain, sir, with the help of examples or of min hashing?
Min hash again I need to be explained,
Yes,
right?
sir. With the help of examples, sir.
Yeah, with example I will here now. With example here we have this example. First, we try to understand what is min hash, right? In the min hash, we created a Boolean matrix previously. Most of you understand.
Yes, sir. Yes.
that Boolean matrix we need to be permit under okay, random permutation pi. So that random permutation pi, why we need to be develop a hash function with help of that random permutation pi. Fine. So this hash of pi of C, what it's saying, the index of the first row in which column has value 1. So this particular okay, this particular statement, everybody needs to be keep it with you. What it's saying, the index of C, the first in the permitted order y pi row in which column C has value 1, that we can treat it as our hash of pi of C, which is going to be min pi of C. So once you understand this one, we will come to understand this one. We have okay, the binary Boolean matrix, and we need to be use a permutation of pi. If you use this permutation of pi is this one, you take a particular row. What is the definition we discussed in the definition? What is the definition we made? Based on that, we need to be compute the signature of the matrix. Signature of the matrix. So here the first value is 1. Index is first value, first column in that row is going to be 1. Then use that one and you need to be develop your signature. So that is the second element of the permutation is the first to map to A1. So here, okay, you have a 2, 1, 2, 1. So this is going to be our signature. The first element we are mapping here and we are okay constructing our signature. Fine. The next we need to become. Next we have to come.
Explain again that how we created the signature.
So here the signature is going to be, suppose okay, you need to be observed here. Okay, this is the first element. So this is the first element. Here 2. Here this is the first element. 1. Right?
Yes.
With help of these two, we have constructed this one. Okay, we'll come back. We'll come back. So now what happens next signature for the okay, next permutation? Next permutation we are performing. That's 4, 2, 1, 3, 6, and so on. Right? Now what we supposed to be? You will understand now the signature here. This is the fourth element. This is the fourth is the first value. And here the Boolean okay, matrix, okay, the next one is going to be the column 3, right? The fourth element of the permutation is the first map to a 1, that is going to be this one. That means okay, here we have 2, 1. 2, 1 is previously, now it is going to be 2, 1, 4, 1. Fine. Means this random permutation we are using and for this okay column 3. Why? Because the column 3 has a first index value is going to be here after 1. This is the remaining. In the remaining, the first one comes here. So that third column. So the third column one we are using with help of the random value 4. And here the random permutation values, what values we supposed to be choose? 0 to 9 only. Clear? Again, you have to be choose. Okay, one more permutation. In that permutation, what values you supposed to be okay, find? Here, okay, you have to find, okay, the why we need to find here 1, 2, 1, 2, okay, like this. Okay, you need to be observe, okay, next, okay, the third one we need to be observe the, okay, the first one, and because of that, okay, we are using 1, 2, 1, 2, so like that. Right, the same thing, okay, again, okay, we need to be observed the same thing in the above example also. The row indexes means, okay, another way is to store the row indexes. Properly you need to be store the row indexes. You will get to know this particular example. So we'll do one thing. We will discuss tomorrow also with this example so that everybody able to understand, okay, more better way of this. I think most of you understand partially. We need, okay, more clarity. We will take another example. We will solve so that, okay, everybody understand this min hashing example. Okay. So initially we need to go ahead here. We need to understand here, right? We need to understand. So we completed min hash and we need to be moved to understand about the locality sensitive. So you receive the min hash values. You receive the min hash values that are, okay, 2141, 1212, 2121. Suppose find the document which records similarity least is going to be S, so that, okay, S is going to be equal to 0.8. The general idea, use the function f of x comma y that tells whether x and y is a candidate pair. So candidate pair means a pair of elements we are going to be used to find the similarity for that purpose. Actually, that particular elements we are going to be used and we are going to be create this candidate pairs. So that candidate pairs are going to be received from min hash matrices only. So in the min hash matrices, we have signature matrix. This is 2 1 4 1 1 2 1 2 1 2 1. This is going to be signature matrix, so that we are going to be use this one to develop our candidate pairs. Okay, so how we need to be develop this candidate pair of document that hashes into the same bucket is a candidate pair. So you need to be find the threshold of S, and you need to be manage the threshold of S is going to be between 0 to 1, and find the candidate pairs. The candidate pairs are going to be use this particular concept, that is going to be m of I comma x is equal to m of I comma y for at least a fraction of S values of I. So we'll see, okay, the main point over here is the hash columns of signature matrix several times. We will arrange similar columns are likely to be hashed to some bucket with high probability, right? So the final unit to be observed here, you have a p bands and a row per band, one signature we need to be observed here. So this is your signature matrix. From this signature matrix, you need to be go for row per band. This is going to be b bands are there, and each one you need to be used. Each one you need to be mapped to one signature here. So partition, we are partitioning this m bands into m into b bands. We'll see that. We'll see that one actually, right? So first of all, I would like to complete here, and I need to come back. For tomorrow, I will give one example to your min hash, and tomorrow we are targeting to discuss about the locality sensitive hashing. So before that, here you need to be observed a simple example for min hashing. I would like to show you. Most of you may understand from here. So here you need to be observed. There is a shingling and there are documents. There are documents. So what you supposed to be do over here? Just a minute. Okay. This is. Here you need to be understand. Suppose, okay, this is the row BEADC for the matrix. So that you need to be understand here BEADC is your shingling. And these are your documents S1, S2, S3, S4. Right? So here, how to find H of S1? How to find H of S1? H of S1 we are finding here in a simple way. That is going to be first you need to be search in this. Where is the one? S1, The A consists of 1 here. Oh, sorry. My document is visible to all of you?
Yes, sir.
Yes.
Right, right. You observe here, S of 1. Here I'm able to use some drawing. I don't know why. Fine, okay. Huh? Here, S1, H of S1 they're finding. How they're finding here? Okay, they're moving towards 2. Okay, that means okay, searching in the column 1. Wherever the first one comes, that is going to be your hash value. That is going to be your hash value. Am I correct? Now, you understand? So H of S1 is going to be equal to A. The same point you need to be go for, you need to find okay, H of S2 is going to be equal to, what is this? This is the last one, that is going to be C. H of S3 is going to be equal to B. H of S4 is going to be equal to A. Again, here this is H of S4 is going to be equal to A. So like that. So then after we need to be find this Jacquard, okay, min hashing and Jacquard similarity, we supposed to be use that min hash signatures, and okay, so the finally we need to be compute okay the values over here. So that okay, tomorrow we will discuss more okay in detail about this example, so that everybody will understand how min hash is going to be computed. Okay.
Okay, sir.
So largely what we need to be understand, we need to be understand singling. After that singling is going to be used to develop what? Boolean matrix. Am I correct?
Yes, sir.
The Boolean matrix, with help of Boolean matrix and the random permutation, both we will use and we will develop the signatures. This concept what we call mini hash. Okay, that mini hash you understand, then we will go for locality sensitive. Okay, right. Any questions? Have a good day and thank you to all.
Thank you, sir.
Thank you, sir.